Define dynamic analysis. Dynamic analysis of three-dimensional structural systems is a direct extension of static analysis. The elastic stiffness matrices are the same for both dynamic and static analysis. It is only necessary to lump the mass of the structure at the joints. The addition of inertia forces and energy dissipation forces will satisfy dynamic equilibrium. The dynamic solution for steady-state harmonic loading, without damping, involves the same numerical effort as a static solution. Dynamic analysis is very useful for engineers for designing, manufacturing and improving engineering equipments. It saves time, money and effort. Saving cost through dynamic analysis. The greatest advantage of dynamic analysis software is that it saves a lot of money. The traditional build and test method is very expensive as the equipment or the machines are first designed and manufactured and put through a number of tests. Manufacture of machine is a matter of big investment. Thus, manufacturing a unit, just for testing, will be a lot of money. But in the case of dynamic analysis you can conduct your test on a virtual processor. Time saves by dynamic analysis. Dynamic analysis save time as you doesn't have to wait for a prototype model to conduct your tests. The analysis enables the engineers to create a virtual prototype and run their tests on it. All these are going to take just a fraction of time. The analysis evaluates the data and also performs the calculations simultaneously. You conduct all your tests on virtual processor. Since the calculation is done by the software you have to invest time for the complex calculations. Dynamic analysis is precise. The calculation, being done by software, is accurate and there is no margin of error. There is scope for human error if the calculation is done manually. Here, the chance is completely absent. The software does all the complex evaluations like kinematic motion and interference between parts.